Okay, today we're going to graph, I'm going to show you how to graph log functions without a calculator. Aren't you excited? So check this out. You're going to be able to graph all of these without using a calculator. I want you to use your brain. And we're going to ease into this really quick by just starting off with a little discovery project I have for you. This is an old problem. We did these before break. How do you graph? A log is an exponent. So they're going to be related. These are going to be related in a certain way. You're going to see in a second. How do you graph this function? Y equals 2. This is an exponential function. Y equals 2 to the x power. How do you graph this by hand? Well, I need to start off with some x values. Is there any x value that we can't put here?
No.
No, there's no limit. So our domain is all real numbers, but obviously we want to stick with 5 good ones. Let's start with -2, -1, 0, 1, and 2. But know that you can, any number can be put in here for x, but we're going to stick with these. No, this is it. So, using -2, these are the best points. When you plug -2 in here, you get 1/4. Plug in -1, you get 1/2. 0, you get 1, 2, and 4. Does everyone understand that?
Resuming workout.
That's funny. Okay, now we're going to graph these 5 points. How do you graph -2, 1/4? Well, you start at the origin, you go 2 to the left and up a 4. -1/2, 0, 2, and 4. The shape of this, you all know very well what it looks like. That's the exponential function. Now let's fill in this information. Your domain. In other words, what x values can we plug in? All the numbers in the world. All real numbers.
Was that a question or both an answer question? Was that a question?
I'm asking you, what's the domain? The domain is all real numbers. Your range is all the y values starting here. Here's your lowest y value. Is this ever going to cross the x-axis? It's not. So your range is going to be y is greater than or equal to 0. Okay? Notice that if I moved along the x-axis and went further, smaller, so if I did -3, I'd get 1/9. And it's going to get closer and closer to the x-axis, but it's never going to go below the x-axis. We have an asymptote, which is this x-axis. So y equals 0 is, we have a horizontal asymptote. This graph is getting closer and closer to the line y equals 0. And our y-intercept is this number 0, 1. Now, just so you know, the y-intercept is the number in front of this 2. So it looks like this, y equals 1 times 2 to the x power. This is your y-intercept, 0, 1. Okay? Now, let's look at the log function. So y equals, it says y equals the log of x base 2. Now I look at this and I have no idea where to start graphing this. So my brain, if someone asks me a question in a foreign language, my brain is going to translate it into the language that I know. What is the language that we know for logs? We know exponential. So how do you convert this into an exponential problem? What's the equivalent? How do you convert this? What goes where? What's the base? 2, and then to the y power equals x. So these two mean the same thing. You got to know that. You're gonna convert it from log to exponential. So now, when I make a t-chart here, normally we put numbers in for x. I would put numbers in for y. Because I can put numbers in here and I would have a hard time figuring out what that is. So what I would do for this, I would plug in numbers for y. What numbers would I plug in for y? I would do these numbers, -2, -1, 0, 1, and 2. So when we evaluate, when we put a -2 here, we get x is gonna be 1/4. When we put a -1 here, we get 1/2. 0, we get a 1. 1, we get a 2. You plug a 2 in here, you get a 4. Well, let's graph this. Graphing these points over 1/4 down 2. Over 1/4 down 2. Over 1 down 1/2. Over 1/2, I'm sorry, down 1. Over 1, 0. I'm very thinking. Wave in the
Am I
camera.
in the tape?
Now you are.
Okay,
Wave.
no, stop that tape and start over.
You too. Over 2, up 1, and over 4, 1, 2, 4, up. Okay, now let's talk about the domain. The domain for this. These are all your x values. Check this out, this graph right here. What are the x values that we can use? What's happening is this graph is going to get closer and closer to the y-axis. So your domain here is now going to be x is greater than or equal to 0. Because it's not going, this, we're looking at this graph right here, it's not going past here. It's going from 0 to infinity. Now our range is, was there any number that we could not take due to the y power? Nope, it was all real numbers now for that. Now we have an asymptote here. Since it's getting closer and closer to this line, that's called x equals 0. That's going to be your asymptote. And we have an x-intercept instead of a y-intercept, and it is 1, 0. Now I want you to take a look at everything here. I want you to look at these equations, and I'm going to take this one out. Look at these two equations. So we have y equals 2 to the x and 2 to the y equals x. What do you notice about them? They're inverses. So those are inverses. Look at the table. What do you notice about them? You have -2, 1/4, 1/4, -2. They're inverses. That's what inverse is you switch them around. Look at your table, your information here. Your domain, when you do an inverse, your domain becomes your range. And your range becomes your domain. Check that out. And instead of y equals 0 as an asymptote, you have x equals 0. And instead of 0, 1, you have 1, 0. Everything gets switched around. Also, you should notice that, what can you talk about these two graphs? They are reflected over the line y equals x. That's what inverses are. So what you should have seen is that these two are, what do you notice about these graphs? They're inverses of each other. Okay, so let's talk about, we need to talk about the transformations. Just like you had transformations, do you remember when we did these transformations in, I think it was chapter 4? Transformations of anything. For example, you had y equals -2 square root 3x minus 6 plus 4. Do you remember all these transformations? What's the parent function? It's y equals the square root of x. And then what did you do here? Let's just review this. What was the first thing we did here? We pull this 3 out. and you have x minus 2. So what was the what's the first thing you start with? This right here. Anything underneath the grouping symbol is the first thing you start with. So what you do, that's your A value. You're gonna flip this number. If it's less than 1, it's a horizontal compression. If it's greater than 1, it's a horizontal stretch. So this would be a horizontal compression by 1/3. Right? Now, how would you mathematically do this when you do your table of values? You're going to multiply the x values by 1/3. The next thing you're going to do, this is the second thing, you're going to go 2 units to the right. Remember, it's opposite here, so it's -2, so you're going to go 2 right. What are you going to do this thing? You're going to add 2 to your x values. Then you go out here, that's C. This is a reflection over the x-axis. And it's also a vertical stretch by 2. How do you do this right here? You multiply the y values by -2. And the last thing is going to be up 4. You're going to add 4 to all your y values. Okay? So you need to be able to describe the transformations here. So let's look at these. These are all log base 10. These are all common logs when it's base 10. So number 1 is the parent function. We're just going to say, we're going to call 1 is the parent function. And how would you get the set of points here? Well, this is y equals the log of x base 10, or 10 to the y power is x. So if I wanted to graph any one of these right here, what I would want to do is strip it of its parent function, which is that. I would make a table of values, and I would plug in numbers for y. Probably only a few of them because of the fact that the base is huge. That's why a lot of times on these problems, if we're going to ask you to graph them, we'll do base 2 or base 3, because otherwise the graphs get too crazy on you. So base 10 is, there's really not many points you're going to want to use for that. So once you establish some points here, now can you tell me how to graph these? Well, this one, think of this, whenever you see something in parentheses, it is that right there. It's a shift left or right. Okay? So how would you describe this transformation? It'd be a shift 1 unit right. Okay? So, in other words, this is going to look like, the parent function looks like this. The domain in the range for the parent function, the domain is going to be x is greater than or equal to 0, and y is going to be all real numbers. But if you're going to move this graph 1 unit right, if you're going to shift it 1 unit right, your domain is going to be greater than or equal to 1, and your range is still going to be y is all real numbers. And they want you to write it in interval notation, your domain and range. How would you write that in interval notation? Greater than or equal to 1 would be, bracket 1 comma infinity. And then this would be negative infinity to infinity. That's a bracket. For the next one, see this 2 plus? Think of this as the log of x base 10, and then with a 2 at the end. This is not a 2 underneath in the parentheses, sort of. This is 2 units up. So if you shift your graph 2 units up, if you took this parent function and moved it 2 units up, the domain's not going to change. It's still going to be x is greater than or equal to 0, and your range is still going to be all real numbers. So how do you write x is greater than or equal to 0? Bracket 0 infinity, and then negative infinity to infinity. So everyone have this 3, it's 2 units up, that's describing the transformation. And the domain and the range is gonna be greater than or equal to 0, and all real numbers. Now this one, you're gonna flip this one over the y-axis, this is gonna be a reflection over the y-axis. And then it's gonna be 3 units down. So what you're doing is you're flipping this, so the graph is gonna look, it's gonna be going the other way. You're flipping it over, over the y-axis, it's gonna be this way. It's gonna be looking like that. So now your domain is gonna be, it's gonna be, x is less than or equal to 0, and your domain is gonna be, and it's 3 units down, so it's gonna be shifted down like this. So for this one, your domain is gonna be from negative infinity to 0, and your range is gonna be still all real numbers. And the last one. This one's gonna be, there's 3 transformations here. It's gonna be reflected over the x-axis. And it's gonna be a vertical stretch by 3. And then it's gonna be 4 units right. Okay? Questions? Anybody have any questions on that? I want to show you how to graph these. This, take out this, it looks like it says n, it looks like ln. So in this graph, y equals 2 to the x power plus 4, you're shifting, this is the parent function, looks like this. So we have this asymptote, y equals 0 right here. By shifting this 4 units up, you have a new asymptote, and the asymptote would be y equals 4. Just wanted you to know that. So this big number out here is going to change your asymptote, and it's going to change the range. So the range for this is going to be y is greater than or equal to 4. Or you could write it like this, 4 to infinity. Now for this one, if you took the parent function of this would look like this. This is a shift 3 units left. So if you move this 3 units left, it looks like this, we've now changed, we have an asymptote x equals -3, that's your asymptote. And you also, your domain is going to change, it's going to be from -3 to infinity, and your range is going to be negative infinity to infinity, same. Okay? I want you to go to the next. This is an important question. You're going to have a writing assignment on this. Okay, you have to describe the transformations. I'm going to ask you, it's going to be graded heavily. I want to know, can you go from the parent function, what is the parent function? I wrote it right here for you, y equals log of x base 2. So everyone should be able to give me the parent function of any function. All you do is take away all this stuff here. You want to look for the base here, it's base 2. So what would be the first thing we need to do right here with this 1/2? Step 1, step 1 is writing the parent function. That's recognizing the parent function. Make sure you can do that. Now let's rewrite this. Let's rewrite this function. What are you going to do? what is important for us to do?
Take out the 1/2.
Yep, take out the 1/2. When you pull 1/2 out of this, what do you get?
X plus 2.
Good job. Okay, so now let's list all the transformations in the proper order. What's the very first transformation? What's the first transformation? It's a horizontal what? Y. It's a horizontal stretch by what? 2. Now, mathematically, how do you do that stuff? What do you multiply the x's by? 2 or 1/2?
2.
So put in parentheses, multiply the x by 2. Next step, what's the next thing you're gonna do? That's B. 2 units to the left. Now how do you do that transformation? You're gonna take your x values and do what? Subtract 2. The third in C and D, this is C and D. -3. The first thing we say is a reflection over the x-axis, and it's a vertical stretch by 3. How do you do C and D in one shot? You take your x values and you multiply them by -3. And the last thing you're gonna do, 1 unit down. I'm sorry, this is y. Why did I write x? Nobody said y. You multiply the y values by -3. And the last thing, you're gonna take your y values and subtract 1. Yes?
Why do we flip the 1/2 in the first place?
That's the effect that it does. It just changes it. You have to,
Is it because it's horizontal?
it's because it's horizontal. The horizontal stretch by a factor of 2. We always flip it, and then if it's greater than 1, it's a stretch. If it's less than 1, it's a compression. Okay? Now, let's graph this. So, what numbers am I going to use? This is why it's important to know the parent function. I'm going to rewrite my parent function as 2 to the y power is x, and I'm going to plug y values now, like -2, -1, 0, 1, and 2. So if I plug -2 in here, I get 1/4. If I plug -1, I get 1/2. 0, I get 1, 2, and 4. So these are the numbers that you have to be able to get the parent function. That's an important step. So step 1, what are we gonna do? Look at your transformations. We bulleted them here, A, B, C, D. We have to first do the horizontal stretch by a factor of 2. So that means multiply your x values by 2. What x values am I talking about? These right here. So you're gonna take your x values and multiply them by 2. So you get 1/2 here. Multiply this by 2, you get 1. Multiply this by 2, you get 2. Multiply by 2, you get 4. Multiply by 2, you get 8. Now some people will do this, they'll keep going here and do x and y. And some people like to rewrite, so keeping these all, it's up to you, I don't care, this is for you. So those are your points so far. Then you move on to step B. B is 2 units left. So you're gonna take your x value and subtract 2. What x values am I talking about? These ones right here. So what's 1/2 minus 2? -1.5. What's 1 minus 2? -1. What's 2 minus 2? 0. 2 and 6. What do I do with these y values? I keep them the same. Are you with me? Third step. I can do these two in one shot. I'm gonna take all my y values in my chart and multiply them all by 3. Take your y values and multiply them by -3. What y values am I talking about? These ones right here. So -3 times -2 is 6. -3 times -1 is 3. And 0, -3, -6. Keeping these the same, so -1.5, -1, 0, 2, and 6. And the last thing you're gonna do is shift your graph 1 unit down. That means take my y values and subtract 1. So if I subtract 1 from here, I get 5, 2, -1, -4, -7. Keep these x's the same. Okay, so let's graph these. Over 1.5, 1.5 up 5. 1, 2, 3, 4, 5. Over 1 up 2. Over 0, down 1. Over 2, down 1, 2, 3, 4. And over 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Now, what should the shape be? It should be that. There's your graph. So you're going to have to write a little essay on the transformation. I want to see these words. I want to see horizontal stretch. I want to see units left, right, up, down, horizontal, vertical. I want to see you talk about what effect it does with the x and the y, what you're going to do. So that's going to be a writing assignment. It's going to be graded like a quiz. Okay? You just have to use complete sentences and just put it all into sentences. I'll have a rubrics for you. So now, what I want you to do for homework tonight, this weekend, I want you to sketch, do 7, 8, 9, 10, and 11. Those are the graphs. And on the back side, these are from the book. These are from your book. You just talk about the translations and the domain and the range. So like if you look at 37, even though it's an ln problem, ln just means log base e. So this is really f of x equals log base e. It doesn't matter what the base is. You gotta look at this thing right here. What does this plus 1 tell you? It's gonna shift, normally your graph for a log looks like that. So with that in mind, it's gonna shift your graph 1 unit left. So what's gonna change here? The domain is gonna change. Your domain is gonna be x is greater than or equal to -1. This one, your domain is gonna be x is greater than or equal to -2. It's shifting 2 units left. So you may wanna sketch a graph of it, and then you can talk about the domain and the range.
So
Yes.
if it wasn't in parentheses, then it would be the other
Right.
one? Okay.
That's a good question. Now look at, I want you to go back to the graphs. Let's just really quickly run through these. Number 7 is in parentheses. This is gonna be a shift 3 units to the right. So that's your B, that's the second thing you would normally do. There's no, the A value is 1, you don't have to do anything there. So this, you'd add 3 units to your x's. That's it. It's a very simple one. Now flip it over. Number 8. This is gonna shift your graph 1 unit down. This is not left, right 1. If it's left or right, it's gonna be in parentheses. The 2 is a you multiply the y values by 2. That's a stretch. Okay, now let's look at the next one. Number 9. That's gonna be a vertical stretch. That's a stretch by 2. and it's upside down. It's gonna be reflected over the x-axis, so you multiply the y values by -2, and this is gonna add, you're gonna add 1 to your y values. There's no left or right here. Number 10, that one has a left or right. It's gonna be left 3 units. And number 11 is one I really wanna pay attention to. This one is, it's kind of written goofy. Can you rewrite this and fix it for me? How does this look rewritten? It'd be -1 times the log. It's base 2, 2x, and then plus 1. See, this 1 is really at the back. So this is gonna be a horizontal compression by 1/2. It's reflected over the x-axis and it's 1 unit up. Okay? So, yes,
Will we take out the 2 and flip it to 1?
yeah, you're gonna, yes, so your first step here would be, you're gonna multiply the x values by 1/2. You don't have to take that out. You don't have to take it out, because there's really nothing, there's no shift left or right, so you don't have to take that out. Okay, you get that? So for this one, you're gonna multiply the x values by 1/2. Then for the next step, you're gonna multiply the y values by -1, and then you're gonna take the y values and add 1 to them. So you may not have to use this whole chart. Okay, that's your assignment.